Okay, so right angle triangle. The definitions are that's the hypotenuse. This side's the hypotenuse. If that's an angle there, we'll call that theta. That's the opposite side. And that's the adjacent side. A lot of people struggle to understand what trigonometry means, I think. I've certainly heard people say they didn't really understand it. So that's opposite, it's opposite the angle. That's adjacent, it's adjacent to the angle. So that side there is opposite that angle, that side is adjacent to that angle, okay? If the angle is over here, this would be the opposite one, okay? And if it was over here, the angle is here, that would be the adjacent one, okay? So, yeah, maybe call that. If the angle was that one, then this would be the adjacent one, okay? And this would be the opposite one, okay? Yeah, because it's opposite the angle and that's adjacent to the angle. So the sine of an angle is defined as, this is just the definitions. The sine of theta is equal to opposite over hypotenuse. Okay? That's just the definition. It's not a case of trying to understand what it means. You have to remember the sine is defined by opposite divided by hypotenuse, okay? The cosine of an angle is actually sine, technically. The cosine of theta is equal to the adjacent side over the hypotenuse, okay? Sine, cosine, and the tangent, and the tan of an angle, sine, cosine, tan, tangent of an angle equals the opposite divided by the adjacent, okay? So these are just definitions, you just have to learn them. I think when people struggle, say they don't understand, they don't realise you just have to accept it. You call sine of an angle opposite of hypotenuse. The cosine of an angle, which you can write as simply cos theta, okay? Sine theta is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent, which is tan theta, okay? So that's basically the basic ideas of trigonometry. You use this by, if you, this occurs for right angle triangles, okay? So that's what that means. So if you call that 5 for 3, okay? This is a well-known triangle where by Pythagoras theorem, by Pythagoras theorem, okay, the square of that side plus the square of that side equals the square of the hypotenuse, okay? So the square of the opposite plus the square of the adjacent, we can call that theta there. So the square of the adjacent plus the square of the opposite side, that's opposite the angle, equals 5 squared, okay? So this allows you to work out an unknown length. If you have two lengths, if you have two sides, you can work out an unknown using this. But that's not actually trigonometry, that's geometry. So I'm just showing you that because if you're going to say, we'll say we don't know what that is, okay? So if you want to work that out, we know that the cosine theta equals cosine is adjacent of hypotenuse, which equals 4 over 5, okay? And 4 over 5 is, so you punch in cosine 4 divided by 5 equals that equals 0.8, okay? 0.8, okay? So theta, you actually take the inverse cosine to do this, but you're working this out. Theta equals, if I'm going to go through this a bit more rigorously, cos minus 1 cos theta equals cos minus 1, 0.8, okay? So what I'm doing is I'm multiplying both sides by cosine minus 1. Sorry, times cos minus 1, okay? Times cos minus 1, okay? And that means they cancel, because that's basically 1 over cos theta, okay? And you're left with basically, the theta's cancelled, sorry, that's not cos. You're left with the theta, okay? I'll take that out. So you multiply it by inverse cos, and you're left with theta only, which equals inverse, you type shift cos inverse, shift cos gives you the inverse, 0.8, okay? Punch it all through calculator and you get theta equals 36.86, okay, degrees. So that's basically how you use, and the same would go for sine, tangent. If you want to work out, if you say you don't know, so in this case, so I rubbed that out, I was dealing with Pythagoras, that was the wrong thing to do there. What I was trying to show you there was that if you work out, you punch cos theta and put adjacent over hypotenuse and put 4 divided by 5 in, you get theta, the angle there must be 38.86 degrees, okay? By crossing out that was actually not relevant to anything, that was thinking Pythagoras. If you work with the sine function, okay, so sine of theta equals opposite over hypotenuse, so we know that the opposite angle is, the opposite length is 3, and the hypotenuse is 5, so 3 over 5, okay? So again, you're taking inverse sine times sine minus 1 on each side, so you get theta and 3/5, well 1/5 is 0.2, so that's equal to 0.6, okay? So those cancel, leave theta equals inverse sine 0.6 equals 36 degrees, okay? So when I punch these through this, that gives you 3/5 is 0.6 plus 1/5 is 0.2. And then take the inverse sine of 0.6, you get 36.86 degrees, which is actually the same result we got here. And the reason it's the same is because it's dealing with the same triangle, although the sides are different, the one of the sides is different, it's dealing with the same triangle and the same angle, so it obviously will be the same, okay? But this shows you that whether you use cosine or sine, it comes out the same. And the tan theta, again, is opposite over adjacent, so you can write that as opposite is 3 over 4, sorry, 3 over 4, okay? So 3/4, so that's equal to 0.75. So again, you multiply both sides by tan minus 1, so you get tan minus 1 tan theta equals tan minus 1 and 0.75, okay? Those cancel to give theta equals the inverse tan, punch it through the calculator, 0.75 And amazingly, that gives you, so inverse tan of 0.75 gives you 36.86 degrees. So again, it's the same result, okay? But because it's the same triangle, and you're dealing with the same angle and the same side, so, but this shows that how it works, okay? So basic introduction to trigonometry. In another lesson I'll go into more detail. There are, at high grade there's more formulas to use. This is more Nat 5 level. So yeah, if you want to try working out, you can work it for any triangle. Not all triangles will give nice clean numbers though. You have to find one which works. Usually from a book. Look at a book to get a triangle with nice clean numbers. Or what you could do is you could one way of working it out, you could make up a length there and a length there, and then you could use, actually that doesn't always work, you don't know if it's going to be right angled. You're best just looking at the book to get a triangle with nice clean numbers, okay? For right angled triangles. For a right angle triangle is written as a right angle triangle. You can write it like that. So look at a book to get triangles with nice clean numbers. I'll do one for another video. I'll look some more triangles up. I can't just make a triangle. If I think of a length say 12 and length say 4, I can't necessarily use Pythagoras to work out that side. You know, that's 12 and 4, because it might not be right angled triangle. I don't know whether those lengths 12 and 4 would create a right angled triangle, and this only works with right angled triangles. So to do that you'd have to use other formulas from high grade maths, but they aren't in the Nat 5 syllabus, so it's not so easy. I know formulas in order to work out if that's 12 or that's 4 what that length is, but for Nat 5 it's not going to be much use. So if you want to look some triangles up with a book, look some triangles up from a book with nice clean numbers to practice this, okay? I hope you find that helpful. Good night. Please subscribe when we get to 1,000. Thank you. I'll put this on to finish actually. Okay.